Hi, welcome to GED Science. Today we're going to be talking about codominance and Punnett squares with codominant traits. All right, so what is codominance? Codominance is when both phenotypes are dominant. So both phenotypes are expressed in the offspring. So before we've talked about just your simple Mendelian genetics or Mendelian inheritance, where you have a dominant allele that is expressed over the recessive allele. So in this case, though, we don't have one allele that's expressed over the other allele. Both of them are dominant, so both phenotypes will show up in the offspring. All right, so let's take a look at this Punnett square. I have a brown goat up here. The brown goat has two B alleles. Then I have a white goat parent over here with two W alleles. So this allele B and this allele W are going to be found in my first offspring for BW. A B allele and a W allele again for BW. A B allele, a W allele, another BW, a B allele, a W allele, and a fourth BW in my offspring. So my genotype probability, and remember, genotype is the combination of alleles that are found in the offspring. So BW is a genotype, WW is a genotype, BB is a genotype. The combination of alleles found in the gene is the genotype. So my genotype probability here is 100% BW because this parent can only donate B alleles. This parent can only donate W alleles. So all four of my offspring are definitely going to be a genotype of BW, 100%. My phenotype probability, now remember, phenotype is what you see or what's expressed. So in this case, what do I see? I see the color of the goat. So the color of the goat is the phenotype in this case with my codominant brown and white goats. So my phenotype probability is 100% brown and white, right? All of the offspring are going to be brown and white. All right, let's take a look at another Punnett square. Okay, so this Punnett square, I have a brown goat up here. I have a brown and white goat parent over here. So I'm going to get a B allele here, a B allele here. The first offspring will have two B alleles. A B allele here, a B allele here. The second offspring also two B alleles. A B allele here, a W allele here. This offspring has heterozygous genotype BW, a B allele here, a W allele here. This offspring also BW. So what is the genotype probability for offspring here? 50% genotypes BB, 50% genotypes BW. What is the phenotype probability for offspring here? I have 50% brown goats, and 50% brown and white goats. All right, let's take a look at one more diagram. Okay, here we have two heterozygous genotypes, two brown and white goat parents. All right, so I will get a B allele here, a B allele here for this first offspring will be BB genotype. Then I'm going to get a W allele here and a B allele here. This offspring will be BW. Then I've got a B allele here and a W allele here. This offspring BW. And finally a W here, a W here. This offspring WW. So genotype percentages here, a little bit more diversity. I have 25% homozygous with BB. I have 25% homozygous WW, and I have 50% BW. Two of the four were BW genotypes. And my phenotype percentages, 25% brown. This one turned out brown. 25% white. This goat turned out white. And 50% probability that 2 of the goats will be brown and white. Both of these offspring turned out to be brown and white. All right, well, that's all I have for codominance for you today. And I hope you join me for the next science class. Thank you for attending today's class on codominance. See you next time.